7 part A, we need to prove the given identity. To prove the given identity, we start from the left side. And we have sine theta plus 2 cos theta over cos theta minus 2 sine theta minus sine theta minus 2 cos theta over cos theta plus 2 sine theta. The left side is more complicated, so we start from the left side and notice that the denominators are different. So first thing, we need to make a common denominator. We are going to multiply the left side throughout by the denominator of the right side. So in the numerator, we have sine theta plus 2 cos theta. And then what we are going to do is we multiply by the denominator of the other term. So we multiply by cos theta plus 2 sine theta. We do the same for the denominator. And we use the same technique for the second term also. We multiply the numerator by the denominator of the first term, which is cos theta minus 2 sine theta. And we do the same for the denominator. We multiply by the denominator of the first term. Now notice that the denominator for the first term is the same as the denominator for the second term. So we have a common denominator. We can just use one big fat straight line here. And for the denominator, yeah, cos theta minus 2 sine theta and cos theta plus 2 sine theta. That is just a difference of squares. You have a minus b, a plus b, which gives you a squared minus b squared. So when we expand the denominator, we have cos squared theta minus 4 sine squared theta. You do not have to expand term by term. That is too troublesome. The numerator is a different case. So we expand this term by term and do the same for the second term. The first term gives us sine theta cos theta. Then that is 2 sine squared theta. Then we have 2 cos squared theta and 4 sine theta cos theta. Okay, for the second term, because of the negative here, you need to use a big bracket and distribute the negative later. So we have sine theta cos theta, and then minus 2 sine squared theta minus 2 cos squared theta plus 4 sine theta cos theta. Okay, now we are going to bring the negative in. So to bring the negative in, let's look at this. Sine theta cos theta. So we have 5 sine theta cos theta plus 2 sine squared theta plus 2 cos squared theta minus. So sine theta cos theta plus 4 sine theta cos theta. That is 5 sine theta cos theta. So we have minus 5 sine theta cos theta. The negative and the negative gives us positive 2 sine squared theta. And we have positive 2 cos squared theta. All over all that. Let's look at this. In the original question, the denominator does not have a sine term. So we need to get rid of this sine square using the fundamental identity of trigonometry, the first identity here. So sine square is 1 minus cos square. And then let's look at the numerator. 5 sine theta cos theta, these two cancel, and what is left is we have 4 sine squared theta plus 4 cosine squared theta, and in the denominator we have cos squared theta minus 4 plus 4 cos squared theta. Now in the numerator, let's see, we can factor out the 4. We have sine square plus cos square. That is just the Pythagorean identity. In the denominator, cos square plus 4 cos square is 5 cos square theta minus 4. This part is just a 1. So we have 4 over 5 cos square theta minus 4. That is what you are asked to show. That is for part A. For part B, you are asked to solve an equation. So for part B here, you need to solve the equation. This bunch of things equals 5. And the solution theta is in between 0 and 180 degrees. So your angle answer is either in quadrant 1 or quadrant 2. And this left side from part A is actually 4 over 5 cos squared theta minus 4. Yeah, the word hence means you need to use the solution from part A. So for this case, we are going to replace the left side with all that. And we write 4 over 5 cos squared theta minus 4 equals 5 here from this equation. And we are to solve for theta in quadrant 1 or 2. We can always cross multiply. Otherwise, just switch place and you're good. So over here, we have 4 over 5 equals 5 cos squared theta minus 4. We can write this as 5 cos squared theta minus 4 equals 4 over 5. Bring the 4 over, and we have 5 cos squared theta equals 4 over 5 plus 4, and that is 24 over 5. Dividing throughout by 5, we have cos squared theta equals 24 over 25. Taking square root, cos theta is plus minus square root of 24 over 25. This is positive and negative, meaning that your answer must be in quadrant 1 or quadrant 2 because you are positive and negative for cos theta. We need to find the reference angle first. That will give us inverse cos. Let's grab the positive one of that. And the reference angle is 11.5. In quadrant 1, theta is just the reference angle 11.5. And in quadrant 2, we have 180 minus 11.5. So that theta is either 11.5 or 168.5.